Welcome back yet with another session. Today we're looking at question 4. We're still on identities and reduction formulae. Okay, the first one, it says we must simplify, and then the second one, it says we must prove that the left hand side is equal to the right hand side. Okay, let's start with 4.1. 4.1, we are given cot squared of angle A multiplied by the sine squared of angle A plus cos squared of angle A multiplied by tan squared of angle A. Okay, first and first here, let's just change everything and write it in terms of sine and cos. So cot in terms of sine and cos, it is cos squared of A divided by sine squared of A. All of this is multiplied by sine squared of A plus, here we have cos squared of A multiplied by tangent is going to be sine squared of A divided by cos squared of A. So you will notice that in the numerator you have sine, in the denominator you have sine. So this sine and this sine, they divide, and then you are left with cos squared of A plus, same thing for this side, you have cos and cos, they divide, and then all you are left with is sine squared of A. And then you will notice that cos squared A plus sine squared A is the same as sine squared A plus cos squared A, and this is a square identity, and this square identity, it is equal to 1. That is 4.1, simple and straightforward there. Forgive my line there, but then let us proceed to 4.2. 4.2, we have to prove, we have an identity, we have to prove that the left hand side is equal to the right hand side. So before we proceed, I just want to identify the quadrants, that what is a pi plus theta and 180 minus theta, in which quadrant do they fall. Before we start, we know that pi, it is equals to 180 degrees. So if I have pi plus theta is the same as having 180 degrees plus theta, and in a case of 2 pi, it's the same as having 360 degrees plus theta, because what is this? 2 multiplied by 180 degrees is going to give us 360. So 180 plus, it's in the third quadrant. 180 minus, it's in the second quadrant. 360 minus, it's in the fourth quadrant. So again here we have a 360 minus, it's in the fourth quadrant. And then a 180 plus, it's in the third quadrant. Now immediately after identifying those quadrants, I can go straight and just simplify. What do I know? I know that sine is negative in the third quadrant, so I'm just going to write this as negative sine theta. Allow me to put the square outside. No? Plus, I have cos 180 minus. 180 is in the second quadrant, and according to our cast rule, according to this rule here, in the second quadrant, cos is negative because we only have sine that has to be positive. So this is going to be negative cos theta there, multiplied by sec. What is sec? Sec is 1 over cos. So we've got 360 minus. We know that 360 minus is in the fourth quadrant here. So in the fourth quadrant, we know that cos is positive. So this is just simply going to be the cosine of theta. And then it's theta there. And then we divide everything divided by, on our denominator, we know that 2 pi minus theta, it falls in the fourth quadrant, and in the fourth quadrant only cos is positive. So that means your tangent here is going to be negative theta, all divided by cot is 1 over tangent, it's 1 divided by, what is your tangent? Tangent is in the third quadrant, and in the third quadrant, yes, tangent is positive. So I'm just going to leave this as the tangent of theta. You can also write this as sine over cos, and you write this as cos over sine. At the end is still going to give us the same answer. If you prefer to write everything in terms of sine and cos, you can still change this to where you write it as sine over cos and change this one and write it as cos over sine. At the end are going to cancel each other, which is just what is going to happen here, because tangent and tangent are going to divide, cos and cos are going to divide. Negative sine squared, be very careful here. Let me just put it here. Negative sine squared is the same as having negative sine theta multiplied by another negative sine theta. Where negative and negative, they multiply and give us a positive sine squared of theta. So negative sine theta squared is the same as this, which is this. Okay, so you're going to have sine squared of theta, and then this negative sign will multiply this one. You're going to have negative 1. All of this is divided by this negative sign will multiply this one. So in the denominator, you're going to have negative 1. Remember, we must prove that this is equals to cos. So we're going to rearrange our numerator. I want you to be very careful with this one. When you rearrange your numerator, you're going to have negative 1 plus sine squared of theta. All of this is divided by negative 1. And then if you take out the negative sign as a common factor from your numerator, you will have negative into 1 minus sine squared theta. All of this is divided by negative 1. Now look what's going to happen here. 1 minus sine squared theta is an identity. 1 minus sine squared theta becomes cos squared theta. Don't forget the negative sign, and then you divide everything by negative 1. Negative 1 divided by this two negative signs, when they divide, they give me cos squared of theta. And by so doing, I managed to prove that my left hand side is indeed equal to my right hand side. And that's how you answer these two identities in the reduction formula. See you in the next video. Bye bye.